Today, I would like to start with a new chapter, GCD and LCM. Let us begin a new chapter, GCD and LCM. Though it is a new chapter, but we can't say it is fully a new one because just before this we learned factorization. We have learned factorization with lots of discussions, assignments. We have even conducted class tests, online class tests. So this GCD and LCM are related to the factorization, which means that without knowing the factorization, nobody can learn or nobody can find out the HCF and LCM of given polynomials. So it's not partially, but it is almost the whole thing is connected with polynomials in the sense the factorization part. Just to recall a few things about the GCD and LCM of numericals. Say numericals. Okay. If you try to recollect what you learned in the lower classes about GCD and LCM. GCD, the other name is HCF. Okay. GCD, the other name is HCF. You may be knowing the full form. GCD means greatest common divisor. HCF means highest common factor. So both GCD and HCF mean the same thing. Okay. So whether you say GCD or HCF, it is the same. Take any two numbers, say for example 20 and 30. If I will ask you to find the HCF or even LCM of 20 and 30, I think most of you will come out with the right answers, and that too without any difficulty, because you know how to find the GCD and the LCM of numericals. So shall we try that? What would be the HCF or GCD? Okay, HCF, GCD are same. What will be the GCD of 20 and 30? It's going to be very important. Yes, somebody said.
60.
Again,
60.
60. 60 is what? We are talking about two things. One is GCD and the other one is LCM. GCD and HCF are same. GCD, then another one is LCM. Are you finding out? Have you already found out? If you have found out, you just tell me. Yes,
10,
today
sir.
before
10.
10 is what? You mentioned the name
G,
GCD or
GCD,
LCM.
GCD of 20
GCD
and 30.
is 10. Okay. Then anybody else? Today I had seen many of you before I started sharing the screen. Evelyn, who else? If I'm not mistaken, Rinsangi, Rufina, Ziltuanga, Ishaka, I'm not sure Ishaka, did I see? Vanlal Rinchana, I saw. Laldu Tuangi, I saw. Joel, I saw. I don't know, Zhongming Sang is able to join us or not. PC Zhongming Sang.
Sir.
You are there. Good.
Yes.
I think because of the rain, you may not be able to walk also.
Yes. I'm in the church.
Yeah. You are still in the church.
Yes.
You didn't go back.
Because the raining.
Because of the rain, you couldn't go back to your house.
Yes.
Oh. Okay, so
Excuse me,
come on,
sir.
start. Mm. Without wasting much time, just share your knowledge how or what is the GCD and LCM of 20 and 30. We are going to connect this numerical example with our polynomials. It's going to be 100% similar. Okay. So it's going to be a very important, it will be very significant for us to learn how to find GCD and LCM of polynomials by taking an example of a numerical which you might have already learned before. Okay, I'm sure that many of us know it, but you might not be aware, but you know it. Okay, so what is GCD and LCM? Apisana said the GCD of 20 and 30 is 10.
10.
Okay, said it is 10. What about others? In such a big class, there is
GCD
only one word,
10,
GCD 10.
LCM
Says it,
LCM 60,
LCM 6. Okay, according to Zirtuanga, GCD is 10, LCM is 60. This is a big classroom. In fact, there are 39 members. Many are just not participating. I don't know why. Come on, what is the GCD and LCM? Even if you say the answers are the same, try to speak out, okay? Okay, now I said it's going to be a very significant one. The reason is the logic how we obtain the GCD and LCM of 20 and 30 is going to be the same in polynomials. We are going to connect this numerical example and polynomials. Okay, I will say before we discuss the detail of how we get the GCD and LCM, the answer 10 and 60. GCD is equal to 10 and LCM equal to 60 are absolutely correct. Okay, these are the correct answers. But now my concern is, how did you know that GCD is 10? How we get that GCD of 20 and 30 is 10. That part is more important because if we know, we can also find GCD of different numbers, even different polynomials. And same is the case for LCM. So coming to the point, the GCD of 20 and 30. In order to find out the GCD, or if you focused at just one as GCD alone, then we will discuss about LCM. To find out the GCD of 20 and 30, the first and foremost thing is to prime factorize 20 and 30. Do you remember that factorization is, the process of writing in product form of prime factors, product form. So this 20, how can you write in the product of only prime factors? There are of course many factors. The factors of 20 will be many, like 1, 2, 3, 4, 5, then 10, then 20. These are the factors of 20. But express this 20 in product form of prime factors. That is called factorization in mathematics. In mathematics, we say factorization is the process of writing in the product form of prime factors. And it is the same in the case of polynomials. So 20, if you write in product form, do you use this method in lower classes to prime factorize? 2 tens are 20, 2 fives are 10, and 5 into 1 no need, because 1 actually is not a prime number, so no need to write 1. So 2 into 2 into 5, that is the meaning. 2 into 2 into 5 is equal to 20. So therefore, when we write 2 into 2 into 5, it is the factorization of 20. So we have written in the product form of prime factors. Similarly, 30. How can you write 30 in the product form? See, 30 can be written as 2 15s are, then 3 5s are 15. So which are the prime factors we can write in product form? It is 2, 3 and 5. All right, 2, 3 and 5. So 30 can be written as 2 into 3 into 5. So 2 into 3 into 5 exactly gives 30. 2 into 2 into 5 also gives exactly 20. So after having factorized, now the last part of writing the GCD is, it's quite simple. The factors which are common means available in both the numbers. Okay, so here we find 2 is common in both, and one more factor 5 is also common. Therefore GCD is equal to 2 into 5, which is equal to 10. Therefore your answer GCD of 20 and 30 is 10 is correct. Okay, is correct. And this is the process. What does it involve? What is the main procedure? Prime factorize them and write down the common factors, only the factors which are common. Okay, so here GCD of 20 and 30 is 10. Now, quite similar to this, if you are to find the LCM, okay, if we want to find the LCM from their factors, once again, from their factors, LCM is right just like GCD, all the common factors also remaining other factors which are not common. Here 2 and 3 are remaining. So 2 into 3. So this will give us 2 into 5, 10. 10 into 2, 20. 20 into 3 gives us 60. So therefore, the LCM of 20 and 30 is 60. And your answers are absolutely correct. GCD is 10, LCM is 60. So that is the main part, the steps involved in finding GCD and LCM of two given numbers, and it's quite similar with the polynomials. Even for polynomials, when you are given two polynomials, the first thing you will do is factorize them. Factorize both the given polynomials, factorize. After factorization, what do you have to do to find the GCD? Choose the factors which are common, okay? And LCM, first common, remaining factors, multiply. But you know, in the numerical examples, the multiplication part is easy, multiplying 2 into 5 into 2 into 3. In order to determine your LCM or GCD, multiplying these numbers are much easier compared to polynomials. So in numericals, you may have multiplied and written the answer. But in the case of polynomials, you know, multiplying two polynomials, multiplying three polynomials, they are not that easy as the numerical examples. Therefore, in the case of polynomials, you need not multiply and write the answer, but simply write down those factors. No need to multiply. That means even in this numerical example, if you write the GCD of, sorry, here LCM of 20 and 30 is 2 into 5 into 2 into 3. It is absolutely fine, correct, okay? It's correct. Even if you don't multiply, there is nothing wrong. But we feel like multiplying. In fact, multiplying these particularly small numbers are easy. But if we don't multiply also, there is nothing wrong, okay? It is absolutely fine and correct. Now, before we take the example of a polynomial, let me tell you one more thing. Let's take an example of two numbers, say 10 and 19. 10 and 19. How can you factorize 10? 2 into 5. How can you factorize 19? Actually, 19 cannot be factorized. It remains 1 into 19 or simply 19. And you see, we don't see any factor which is common. Okay, we don't find any factor which is common. In such case, when you don't have any factor common, the GCD will be, can anyone tell us what is the GCD of 10 and 19?
190.
190. Are you sure? What about others? We have seen 10 can be written as 2 into 5, whereas, sorry, 10 can be written as 2 into 5, whereas 19 can be written as 1 into 19 or simply 19. We cannot factorize more than that. So in such case, the GCD is 1.
1.
Okay, because we learned just now, we took the example of 20 and 30. GCD is the factor which is common in both. Common factor, okay, the one which is only common. But here we don't have any factor common. But in fact, 1 is a factor of any number. Only thing we don't write. Normally we don't write. We don't include 1. And moreover, we are looking as far as possible only prime factors. 1 is not a prime number, so we felt that it is not required. But in some cases where we don't find any factor which is common, you must not forget 1. 1 is common. Okay, so GCD of 10 and 19 is 1. And this pair of numbers 10 and 19 whose GCD is 1 are called co-prime numbers. That means 10 and 19 are co-prime. They are called co-prime. Co, then prime. Co-prime. Okay, 10 and 19. The numbers 10 and 19 are called co-prime. How do you know? Why do we call 10 and 19 co-prime? That means those pair of numbers, it can be even more than two numbers, but among them, if there is no common factor other than 1, that means in short, those numbers, when we find out their GCD, if it is 1, they are called co-prime. Okay, they are called co-prime. The example which we took before this 20 and 30 cannot be called co-prime because their GCD is not 1. Similarly, if you find two polynomials, after factorization you don't find any common factor. So definitely you have to write GCD is equal to 1. The two polynomials can be called co-prime. So that is the meaning of co-prime. Okay, you can give many other examples of co-prime. For example, if you take 21 and say let's say 4. Okay, 21 and 4 are co-prime. 21, if you factorize, we can write is it 3 sevens are 21, 3 into 7, 4 can be written as 2 into 2. We don't have any common factor, so definitely 1 is the only common factor between 21 and 4. Therefore GCD of 21 and 4 is 1, and hence we can call 21 and 4 as co-prime numbers. Co-prime, simply co-prime. So I hope it's clear about how to find the GCD and LCM and what exactly GCD and LCM means, how to find. Okay, so if you make use of this idea in polynomials, you can GCD and LCM. So let's take one example which I have taken from the textbook. Okay, this example is taken from your textbook. The question is like this: find the GCD of 3 plus 13x minus 30x square, and this is one polynomial. Here we have another polynomial. Okay. Find the GCD and LCM. Here no need of finding LCM. It can be asked together, find the GCD and LCM. In that case you have to find both GCD and LCM. But if the question is asking only about GCD, write only the GCD part and no need to write LCM. And similarly, if you are asked only LCM, write the LCM, no need of finding out GCD. So here find the GCD of two polynomials. One is 3 plus 13x minus 30x square. Another one is 25x square minus 30x plus 9. So there is nothing to be, so panic. Don't simply think that it's a big question. Don't simply think that it might be a difficult one. Just remember how we have to find GCD. You remember that GCD is after factorization the factor which is common in both, common factors. So what knowledge is required here? Factorization. These given two polynomials must be first of all factorized. For that we have learned factorization first. Mostly I was focusing more at factorization by splitting middle term and a few examples, simple one using some algebraic identities. So by seeing the polynomials, you must be able to know, you must be able to identify yourself, okay, that should I factorize by splitting middle term or some other ways, okay. So if you look at this polynomial, you see, first of all, when we write polynomials, we used to write the polynomials in standard form. Standard form, we mean the uh, descending order, okay. We used to write the highest power of the variable first and then slowly decreasing. So that is called descending power, descending order, sorry, descending order. So the polynomial usually we write in descending order. So if you first write the given polynomial in descending order, uh, since one minus comes in the beginning, minus is being taken out common. Remember here, when we take minus common, remember all their signs inside will be changed, okay. So this minus 30x square square inside the bracket plus 13x becomes minus 13x inside the bracket, and that of simply 3, which means plus 3, becomes minus 3 inside the bracket. The reason is we have taken one minus common outside. If you don't take this minus common, then you must write their signs as it was, okay. There minus is just taken out common. It is up to you. If you don't take out minus common is also okay. If you take it out, just remember that this minus sign has to be handled carefully. But one thing is, just first term, starting one, if it has minus sign, perhaps you may find difficult. You may not have seen actually. So taking out minus common is rather easy, so that you don't have minus, and just write minus till the end, that's all. And the rest of the thing solve as if there is no minus in the beginning. That means concentrate at this 30x square minus 13x minus 3, as if you don't see this minus, okay. It's only a matter of writing minus till the end, till the end. You're simply writing the minus sign without forgetting. That's all. Okay. What is inside the bracket is now 30x squared minus 13x minus 3. After splitting the middle term, we get this one. Now finally, this is the factorized part. This is the one. So after factorization, we get minus 5x minus, minus is outside, okay? Minus, you forget it. 5x minus 3 into 6x plus 1. This is one part, the factorization of the first polynomial. Similarly, check the second polynomial. The second polynomial here it is 25x squared minus 30x plus 9. So this 25x squared minus 30x plus 9 after factorization, you get 5x minus 3 whole thing square. 5x minus 3 whole thing square means 5x minus 3 into one more 5x minus 3, like this. 5x minus 3 whole thing square is 5x minus 3 into 5x minus 3. So if you look at these two factors, one is here, now we have another one here. Do you see anything common? You see 5x minus 3, 5x minus 3 are common. Therefore, definitely GCD will be 5x minus 3. Therefore, your GCD is 5x minus 3. Okay, students, this is how we can find GCD. It's nothing but first we need to factorize. So factorization plays here a very important part. Without knowing the factorization, I don't think we can find the GCD or even LCM. So the knowledge of factorization becomes so significant once again here. That is, after factorization, write down the factor which is common. That gives us the GCD. That's all. I have also taken one more example from your textbook. Here you see, find the GCD of what? This polynomial and this polynomial. Now think over, okay? Think over this. Whenever you are given a polynomial, you must see to yourself, okay, whether you know how to factorize them or not. By just seeing the face or the expression, you will be able to get some idea to how you can factorize. So seeing the polynomials factorize, here the first polynomial after factorization we get factors x plus 1 into x squared plus 1, x plus 1 into x squared plus 1. The another polynomial given x to the power 4 minus 1, after factorization we have x squared plus 1, x plus 1 and x minus 1. Okay, now we have three factors here, though the expression looks so small, but it has got three factors. In fact, when you multiply all these three, you will exactly get x to the power 4 minus 1. It will be exactly equal to x to the power 4 minus 1. So x to the power 4 minus 1 after factorization we get x squared plus 1, x plus 1 and x minus 1. That's all. After this, the rest of the thing is so simple. What is that? Write down the factors which are common. Write down those factors which are common. You see here, do you see x plus 1? In the next polynomial also we have somewhere x plus 1, and another factor x square plus 1 is also available in the second polynomial also. That means x plus 1 into x square plus 1. See, I told you already many a times that when we write in product form, any one factor can be written first. There is no hard and fast rule. There is no restriction. I mean, there is no nothing that we cannot write wherever we like. They can be written. Any one can be written first. So that property is called the commutative property of multiplication. Like for example, 2 into 3 can be written as 3 into 2. So therefore, there is nothing wrong in writing any one first. The main idea behind is how to write the GCD. GCD is those factors which are common. Common phat chuan animai. So here it is written the GCD is, no need to write all this. This is just for your understanding, or it is an explanation part. You can just write, therefore GCD is the common factors are x plus 1 and x square plus 1. X plus 1 into x square plus 1. And I told you we need not multiply. Write your answer like this only. No need to multiply. No need to multiply these two factors, x plus 1 and x squared plus 1. This is the answer, GCD. So that is just for your understanding. It is written down here, the answer, that GCD of the two polynomials, suppose one is p of x, another one is q of x, their GCD is x plus 1 into x squared plus 1. So if you check one more example here in this question, find the GCD of 2x square minus 4x, comma 3x to the power 4 minus 12x square and 2x to the power 5 minus 2x to the power 4 minus 4x cube. Do you find any change, something new from whatever we have discussed today? Do you find anything different from what we have discussed? The difference you might have observed here is there are three polynomials. The examples we have seen before had only two polynomials. We took numerical examples. In that too, we had only two numbers. We talk about 20 and 30. So here the difference is there are three polynomials. So there is nothing to be so difficult in this. The GCD, the idea behind remains the same. First, factorize. After factorization, write down those factors which are common. That I am repeating again and again. Those factors which are common. Okay. So in this, the first polynomial 2x square minus 4x, after factorization, it is in the product form 2 into x minus 2. 2x into x minus 2. The second polynomial 3x to the power 4 minus 12x square, after factorization is written here 3x square into x plus 2 into x minus 2. Then the third polynomial 2x to the power 5 minus 2x to the power 4 minus 4x cube. is after so after factorization, the factors are 2x cubed into x minus 2 into x plus 1. So remembering how to find the GCD, start checking the common factors. Which factors are common? Okay. Now here we can see all. 2x into x minus 2 in the first polynomial. After factorization, these are all in product forms. Okay. 2x into x minus 2 is in the first polynomial. Second polynomial, we have 3x square x plus 2 into x minus 2. The third one, 2x cube x minus 2 x plus 1. Do you see here 1x? Here it is x square, so at least one x is common. Here also x cube. That means in all the three, one x is common. So in GCD, first of all, one x is common in all. X is common in all three polynomials. Then what else? Is x minus 2 present in all? Here is also x minus 2. Here is also x minus 2. So therefore, the required GCD is x into x minus 2. X into x minus 2. See, regarding the numbers here we have 2, here we have 3, here we have 2. That means though there are 2 in two polynomials, we are looking for common in all. 2 3 2. That means nothing is common in all the three polynomials. Therefore, what is common in all the three polynomials is x into x minus 2. So the GCD is x into x minus 2. So I hope you get at least some knowledge about how to find GCD. We started with a numerical example, which I think we all know how to find GCD and LCM of numbers. Okay, numbers. But we found today the idea that we use to find the GCD in the numerical example is exactly followed. It is exactly the same in the case of polynomials. So we saw the main idea or points in this GCD is first thing, factorization. Without factorization, we cannot find GCD. The first thing is to factorize. Factorization we cannot avoid. We cannot skip to the factorization part. By skipping the factorization part, we cannot find GCD. There's no way you can find GCD. Then second part for GCD, I mean, write common factors. Depending upon the polynomials given, there can be only one factor which is common in both. There can be two factors common in both. There can be even three or four or many more factors. So GCD is all those factors which are common. And there are even examples where we don't find any common factor. In that case, the GCD is 1. Is this okay?